Question 9, the constant a is such that the integral of 6x ln x equals to 4 with the limits a and 1. We have to show that a is equals to exponent, so e to the power of whatever the function is. Now, in the first step, we'll integrate this function 6x ln of x. We can keep this outside. We can apply the limits at the very end. And we'll first integrate x ln of x and then put the limits and put it equals to 4. So when we have to integrate two different functions, we'll apply integration by parts and we'll use the late rule. So the log function is ln x. So u would be equals to ln of x and du would be equals to 1 upon x. Similarly, v dash would be equals to x. So v would be x squared upon 2. Now applying the formula for integration by parts is if we have u dv, so we get vu minus v du. Substituting this in the formula, so our u is ln of x and v is x square upon 2. So x square upon 2 ln of x minus v du. So v is x square upon 2 into du. So that would become x square upon 2 into x. That's 1 upon x. So x and x will cancel out over here. And not to forget, we still have a 6 outside. So we'll get x square upon 2 ln of x minus 1 upon 2 integral of x. And integrating x, we'll get x square upon 2 ln of x minus x square upon 2 again. When we integrate x, so we get x square upon 4. And then we multiply the whole expression by 6. So we'll get 3x square ln of x minus, and then 6 into 6 upon 4 would be 3 upon 2 x squared. And now we'll substitute the limits a and 1 and then put it equals to 4. So for substituting a, we'll get 3a square ln of a minus 3 upon 2a squared minus 3 into 1 is 1 into ln of 1 minus 3 upon 2 into 1. ln of 1 is 0. So we can get 3a squared ln a minus 3 upon 2a squared minus minus that will become plus 3 upon 2 and this term will become 0 equals to 4. Now we have to make, so a the subject and a square will be on the other side. So we'll first take 3 upon 2 on the other side and we'll get 3a squared ln of a minus 3 upon 2a squared is equals to 4 minus 3 upon 2. So 4 minus 3 upon 2, that will become 5 upon 2. And let's check if we have any 5 upon 2. So yeah, we have 5 over here. And then taking 3 upon 2a square on the other side, we get 3a square is equals to 5 upon 2 plus 3 upon 2a squared. And this is 3a squared ln of a. Continuing the working over here, we'll get, okay, so 5 plus 3 is 8 upon 2, that is, so 5 plus 3 a squared. Okay, and now we'll divide by 3a squared on both the sides. So we'll get ln of a is equals to 5 upon 6 a squared plus 3 upon 3 and 3 will cancel. So when 3 divides by 3 upon 2 over here, this 3 and 3 cancel. So we'll get 1 upon 2 and a squared will also cancel out. So we'll just get 1 upon 2 over here. So we have 5 upon 6 and 3 upon 6. Yes, that will be 1 upon 2. So that's fine so far. And then finally, a would be equals to e to the power of 5 upon 6a squared plus 1 upon 2. And this is the same expression because over here 1 upon 6 has been taken common out. And if we take 1 upon 6 common out over here, we can write this as 5 e to the power of 1 upon 6. So this will become 5 upon a squared and plus 3. As 3 into 1 upon 6, that will become 1 upon 2. And yes, there was a squared over here. Okay, in part B, it says verify by calculation that a lies between 2 and 2.1. Now, the way to do that would be, we'll write the equation as a minus e to the power of 1 upon 6 into 5 upon a squared plus 3. And first we'll substitute and write it equals to 0. First we'll substitute a is equals to 2. So we'll write 2 minus e to the power 1 upon 6 into 5 upon 2 square, that is 4 plus 3. And we'll find the answer for this value. So this will become e to the power of, so 5, first let's do 5 upon 4 plus 3, that is 17 upon 4, multiply by 1 upon 6, that is 1 upon 24. So you'll get e to the power of 17 upon 24, and then 2 minus the answer, we are getting minus 0.0306. And then substituting 2.1, you get 2e 2.1 minus e to the power of 1 upon 6. And then let's do 5 divided by 2.1 squared, then plus 3 multiplied by 1 upon 6, then exponential answer over here, and then 2.1 minus the answer, we get 0.108. So we get 5 upon 2.1 squared plus 3 equals to 0. Now this change of sign basically means that the root lies between. So we can just write change of sign from minus 0.0306 to positive 0.108 shows that the root lies between 2 and 2.1. And part C, we have to use the iterative formula based on the equation in part A to determine A correct to 3 decimal places. So we know that A can be written as e to the power of 1 upon 6 into 5 upon A squared plus 3. And then all we have to do is start off with the initial value. So the initial value we can take as the middle value of 2 and 2.1. So let's take 2.05. Now let's substitute this into the calculator. We get e to the power of 1 upon 6 multiplied by, and this will become 5. So we can write it in bracket form, 5 upon 2.05 whole squared, and then plus 3. And we'll close the bracket, and we'll get 2.01. So this answer is coming, the second value is 2.01. And then in the same value, instead now we'll write 2.01 over here. And okay, so now we're getting 2.026. And we have to give all of these to, okay, so one mistake, we have to give all of them to 4 decimal places. So 2.0264. And we'll have to substitute this exact value into the equation again. So substituting this over here, we'll get 2.0264. I will whole square the equation, and we'll get 2.019 now, 2.01968. So that will be 2.09197. And then substituting this back into the equation. So 0197, we get 2.022, 2.0224. And we have to give the answer correct to 2 decimal place. So we have to make sure we get our answer the same correct to 2 decimal place. So substituting this back again, we get 2.0224, and we get again 2.021. 0.0213. And let's do it one more time to make sure the answer is the same to the second decimal place. So 2.0213. And we are getting again 2.02175. So again, we are getting the answer to 2 decimal places. So the final answer for A will be 2.02.